Okay, so we're on to question number 4 from our Shadow 2018 paper 2, and we're going to start with this one here. So it says show that the sum from 1 to 15 of 2 plus 4r plus 2 to the power of r is 66,044. So the first thing that we need to do here really is we need to realize that you are allowed to break this up sort of in the following way. Okay. And I could break it up even more than this, but I think this is going to be fine, okay? So from 1 to 15, so the idea is that you sub in 1 to any r's. Notice 2 doesn't have an r, right? So it's just the number 2. So you sub in r as 1 into all of these places, and then r is 2, and then 3, and then 4, and then you add them all together, all the way up to 15. So the first one is 2. So you have 2, and then when r is 2, it's 2, and when r is 3, it's 2. So there's going to be 15 terms. It means there's going to be 15 lots of 2. So that one there, you can just say that that bit there is going to be 30, because you're going to have a 2, a 2, a 2, a 2. You're going to have that 15 times in this whole thing. Okay, how about the other ones? So like I said, there's loads of ways you could do this, but I'm going to just sort of show you just one way of doing it. So this one over here, well, if we sub in 1 and we look at only this bit, have a think about what happens. You get 4, and then you get 8, and then 12, and we're being told to add these things together. Okay, so this is an arithmetic sequence. So 4r makes an arithmetic sequence where a is 4. The difference, did you notice the difference there was 4 as well? And n is 12. So this is in the formula. N is 12, n is 15, I think. The formula is in the booklet for this one, but the idea is that you should do n over 2 times 2a plus n minus 1 times the difference. Okay, and if you do that, you get 15 over 2, you get 2 lots of 4, you get, let's just call that 14, shall we? 14 lots of 4, okay? And then that would give you your sum for that part there. So let's just start typing that in. So what's the fraction? It's 15 over 2. I think it's fairly safe to call that 8 plus 14, 4. And then an ending bracket on there. So I get 480 from that bit. Okay, so 480. So far I've got my 30, I've got my 480, and then it's time to handle this final bit. So looks like it should be quite big to make the whole thing add up to 66,000. Let's just plug a few numbers in first of all to work out what's going on. So when you put r in as 1, you get the number 2, don't you? When r is 2, it's 2 squared, so it's 4. Yeah, remember, we'd be adding them all together because of this symbol here. What's the next one? The next one's going to be 3, so it's going to be 8. Okay, and so on. So what kind of sequence is this? This is a geometric one. So we're going to go work that one out over here as well. So the numbers are a bit different for this one, the numbers that you want. So you want a is 2, it's r, so there's a ratio, not d, we say r. So r is 2 and n is 15. And this is another one that is there in the booklet for you. So this is going to be, the sum is going to be 1 minus r to the n over 1 minus r. So that's one way that we can sort of do the sum. Yeah, so let's do that now. So that's 2, that's 1 minus 2 to the 15. That's where the really big number's probably coming from. Over 1 minus 2. Okay, and if I start typing that all in now, what do I get? So fraction bar, I've got 2 brackets, 1 minus 2 to the power of 15. Please be careful with the bid mass on this one here. Sometimes it causes people some problems. And then 1 minus 2. So hang on a moment, I've got syntax error. What have I done wrong? 2, 1 minus, there we go. Right, needed to press the arrow key one more time. Right, there we go. It is a big number, just as expected. So 65,534. Okay, so finally, what I'm going to do is I'm going to say that this is the sum of this whole thing. It should be 30 plus 480 plus the number that we just worked out. And this should hopefully be 66,044. So plus 30 plus 480. Yes, that is in fact what it is. So there's loads of other ways of doing this. I could have done it with triangular numbers. I could have broken this bit up here more and so on. But just in the interest of time, I think this is probably one of the quickest ways of doing it. Okay, so there we go. That's our part A. And then we're on to part B. So this is playing at the fact that, you know, this symbol, this sigma notation is used in a few different ways typically. So notice how it's being used in this question. So the first term is 4, the second term is -1, and it says the term sort of 2 above another one is the same. That's what this is trying to say. So how do you read that? Well, you read that as, so T3, for example, if there's a 3 there, it means the R bits are 1. So it's trying to say to you that the third is the second. Sorry, the third is the same as the first. That would also mean, wouldn't it, the fourth is the same as the second, and so on and so on. So what's going on in this series is it's not geometric, it's not arithmetic, anything like that. It's just a sequence that goes 4 plus a -1 plus a 4 plus a -1, okay, and so on. That's all it's doing. So sometimes on these kind of questions, you have to spot that there's a pattern, and this is an example of that. So it says you're adding from 1 to 50. So from 1 to 50, there are 50 numbers. So that's going to mean that you've got 25 lots of 4, and you've got 25 lots of -1. And you're just going to work them out and add them together. Yeah, so that's going to be 100, isn't it? That's going to be -25. Okay, so, you know, 75 is the sum to 50 terms. Okay, so you've seen a pretty good example there of how the sigma symbol can be used in a couple of different ways.